Okay, now welcome back. The next topic is cause of refraction. That is, why does the refraction take place? Now it's very simple. Refraction takes place because there is a change in the speed of the light. Now what do you mean by this? Change in speed of light means what? Whenever light ray will travel from rarer to denser medium, like that is air to glass medium, what is going to happen? We have already seen that the light ray will bend towards the normal, that is rarer to denser, its speed is going to reduce, and when it goes from denser to rarer medium, its speed is going to increase. Okay, so because of the dense particles, the speed of the ray of the path bends. Okay, and bending the rules we have seen towards the normal, when it goes from rarer to denser, denser to rarer, away from the normal. Let's go ahead quickly with the next topic, that is the laws of refraction. Now laws of refraction are pretty much similar. The first, we have already seen this when we had studied laws of reflection. Now what is that? First law goes like this: the incident ray, refracted ray and normal all lie in the same plane. It's a very simple, we have studied this in the case of reflection also, so I will not spend much of my time in this. Now what interests me is the second law of refraction, that is mu is equals to sin I upon sin R. Isko samajh lete hain now. Now what do you mean by this? Okay, let us see. Let us take a medium, okay, or rather two mediums. One is an air medium and another is a glass medium. Okay, pay attention everyone carefully. And there is an ray which is incident at a certain angle of incidence, and there is refraction that is taking place. Okay, so I have a certain angle of incidence and I have a certain angle of refraction. Now for this particular angle of incidence and this particular angle of refraction, if I take the trigonometric ratio sine of angle of incidence and sine of angle of refraction, if I take the ratio, then I will get a certain value. Let's call this value as x. Okay, एक certain value मुझे मिलेगा. And now what I am doing, I am changing the angle of incidence. Okay, I will use a different color chalk for this. I will take this, and then again my angle of refraction will also change. You agree to this? So now, so for the first angle of incidence, refraction. Okay, so for the first case we had named it, नहीं हमने कुछ नाम नहीं दिया ना, I1 और R1 बोलेंगे इसको. So here the value was I1 and here the value was R1. Now for the second case, see this, I am keeping the value as I2 and I am taking the value as R2 now. Okay, so now in the second case I am taking I2 and R2. And what did I do in this particular case? I took the ratio, sin I upon sin R. This is my formula. Okay, so what I'm doing, sin I1 upon sin of R1, and I get one particular value. Correct? Now here, next what I'm doing is sin I2 upon sin R2 I'm doing. And now students, pay attention very carefully. When I do this for this next pair of angles, again the value that I will get is x. Means what? For as many number of angles of incidence where the refraction is taking place, if I go on taking the values of, or if I go on taking the ratio of sine of angle of incidence to the sine of angle of refraction, I am going to get a constant value. And this constant value is nothing but called as refractive index. Everyone there with me? This particular value is called as refractive index, denoted by the symbol mu. Okay, like this, mu. Okay, so now this is it. Now let us understand what is the use, why we are going to use this particular value, refractive index. Okay, so refractive index will tell me by how much amount the speed of the light is going to reduce, or when it enters from rarer to denser medium, what is going to happen? The speed of the light is going to reduce. Now what is the speed of light? In air it is 3 into 10 raised to 8. So when it is going to into denser medium, by certain amount it will decrease. correct? So by certain amount, by how much, okay, that particular value will be given to me by this particular value called as refractive index. So this value, by how much the speed is going to reduce when it goes from a denser to rarer medium, and from rarer to denser medium when it goes, by how much the speed is going to increase, this information will be given to me by this particular value called as refractive index. Okay, so now anyways, before we go ahead, there is a small topic that we like to cover: effect on speed, frequency and wavelength of the light. That is, now we all know this formula: V is equals to F into lambda. Okay, so now see this, students, speed of the light whenever it goes from rarer to denser medium, what will happen? We all know this now very well. Speed of light will decrease, okay, and denser to rarer, speed of light will increase. Now frequency, there is no effect, so I have put a cross over here, if you can see. Okay, there is no change in frequency whenever there is a change in the speed of the change in the medium of the light. Why? Because frequency depends upon the source of the light. Now what do you mean by this? Source means from where the particular light has generated. Okay, like if I take a candle, so candle will be my source of light. If I take an LED bulb, this is a different source altogether. Are you all understanding this? If I take a hot iron from hot, so these are my different sources through which the light is coming out. Okay, so the frequency depends upon the source of the light, and hence there is no change in the medium, there is no change in the frequency if there is a change in the medium. Okay, let's go to the third parameter, that is lambda. If we can see from this formula, V is equals to F into lambda, we can see there is a clear relationship. So therefore, whenever the speed decreases, the value of lambda will also decrease, because V is equals to F times lambda, speed will also decrease. And here, when speed increases, the value of lambda will also increase. Okay, I hope you all have understood this. Let us continue in the next part. Thank you.